My name is Kristen Carter, and today I'm here to introduce you to Reaveley engineers and life as a structural engineer. I've been with Reaveley for a little over a year, full-time for about 2.5 months. Reaveley is a local structural engineering firm, but we're licensed in, I think, 28 states and have completed projects throughout the country as well as internationally. We're the second oldest structural engineering firm in Utah. We celebrated our 50th anniversary in April of 2022. And we've ranked as the top structural engineering firm in Utah per annual revenues every year, dating back to 2012. This includes structural engineering for new buildings and seismic design, as well as seismic analysis and retrofit for existing buildings. We also do BIM project coordination, concrete and facade restoration, sustainable design through our LEED accreditations, and participation in the SE 2050 initiative, which is something that's unique to Reaveley right now, and structural forensic analysis. We focus mostly on medium to large public projects, and we primarily design in steel, masonry, and concrete, which includes some tilt-up. You see our work all over the valley and state and beyond. Here's some examples of buildings that we were involved in bringing to life. Nichols Theater, which opened in 2016, is a concrete within steel structure. The concrete is used to dampen the exterior sound and enhance acoustics within the performance hall. And this structure won Utah Construction and Design's Outstanding Project of the Year in 2016. The Salt Lake City Library, which opened in 2003, features steel moment and braced frames as well as concrete frames and shear walls. And one interesting thing about this building is that 90% of the structural design is exposed, so it's a great place to go and see our work. I was involved in the Utah State Capitol seismic retrofit. The original construction was in the early 1900s using a reinforced concrete frame, but it was found to have seismic deficiencies. So in 2008, we completed a $220 million project that earned multiple awards and installed 256 new base isolators under the foundations of the historic building. And the base isolators will make the building more resilient to seismic events. Reaveley has been involved in every phase of the Huntsman Cancer Institute construction. It originally opened in 1999, but expanded in 2004, 2011, and again in 2017. One interesting thing about this building is the way that it uses one-way concrete pan joists to control vibrations for sensitive laboratory equipment. Reaveley designed the Summit at Snowbird, which opened in 2015. It was constructed at 11,000 feet, and it is the highest year-round alpine facility in the country. These incredible windows are equal in size to 2 IMAX theater screens. Reaveley designed the first Rice-Eccles Stadium expansion, which opened in 1998 and facilitated the 2002 Salt Lake Winter Olympics opening and closing ceremonies. University of Utah campus, Reaveley also did the Marriott Library seismic upgrades in 2008. You can see the buckling restrained brace frames that were installed on the exterior of the building to protect the students and the rare collections in the case of a seismic event. A project on the University of Utah campus is the central parking structure, which opened in 2015. You can see in this image that there's a soccer field on the top of the parking structure, and so this was a unique challenge because parking structures typically aren't designed for this type of dynamic loading. So what is it like working at Reaveley and working on interesting structures like this? The day-to-day for an entry-level engineer looks like. And Reaveley is involved through the whole design process, so some days I attend coordination meetings with architects, clients, and other engineering professionals. Some days I work on design using softwares like RAM, SAP 2000, eTabs, or Excel, and sometimes I even work by hand using MathCAD or Sketchulation. Some days I coordinate with the drafting team or Redline to communicate changes to the drafting team. As an intern, I did a lot of construction administration, specifically submittal review, and I've started doing site visits as well. Our more senior engineers will respond to requests for information and coordinate solutions when something changes in the field. I'm also involved in the sustainability studies for SE 2050. And like I mentioned, this is unique to Reaveley right now because we were the first, and I think so far the only firm in Utah to have committed to the carbon neutrality initiative. So what we do for that is material takeoffs and documentation using Revit and an add-in called Beacon. And sometimes I'm involved in analyzing existing structures for structural and seismic capacity. So here are some examples of what I see on screen during my day. This is a program called RAM Structural System, which we use for structural design. It's mostly for simple buildings, and it allows you to lay out the framing of the structure. Once you have your framing input, it'll design the beams, columns, walls, etc. Design process. This is one of the ways that we communicate with architects, clients, or our drafters about the design. Everything is designed and we move into construction. We review submittals to make sure our drawings have been interpreted correctly. And this is an example of what a submittal looks like before I clean it up and send it back to the general contractor. An example of what a sustainability study might look like using the Revit add-in Beacon. Once the building is fully modeled, we can use Beacon to tabulate all of the materials and show us the global warming potential of all of the materials in the structure so that we can keep tabs on what materials we're using and use that data to improve our outcomes. From ASCE 41, and these are examples of things that we might look for when we're evaluating an existing building for seismic capacity. As an entry-level engineer, here's some career skills I wish I'd picked up before I started working full-time. The first is a top-to-bottom understanding of design. The theoretical knowledge that you pick up in school of designing a single element isn't enough. You need to know how to put it all together. You need to understand the load path and how forces are transferred. In my opinion, detailing is the hardest part of our job. The second is software. I wish I'd spent a little bit more time building my skills with structural analysis and design software because they definitely make our jobs easier. I also wish I'd had exposure to structural analysis of existing buildings because that's very different than designing buildings. We don't always have access to all the information we want, especially with historic buildings, so you have to understand the principles and how to apply them to make your best judgments. The last is terminology. I wish I'd had more exposure to construction terminology and other industry terminology because that would make my job a lot easier. If you have any questions about our services or what we can do for you as engineers, please don't hesitate to reach out.